So, okay, you do a hackathon, 2 weeks later, you get into YC. Roughly a month later, you're flying a drone.
What we've seen in Ukraine in the past 2 years, the drones and like being able to just throw 1,000 of something at somebody is extremely useful. But now we can't run an autonomous mission because we don't have GPS. What if we just use like Google Maps? And what if we fingerprint the maps and match them? When you buy better sensors, what you're buying is less noise. AI is very good at denoising. Just take a cheap sensor and just denoise it, and you can do something for like 1/100th the price. I'm Ian Laffey. I'm the CTO at Theseus, and we're building GPS-denied drone navigation tools. So basically, we've got a little triangle. You put it on the bottom of your drone, and it lets it fly without GPS.
Well, thank you so much for joining me here. This is going to be fun. You came here to the Astronis office.
Yeah,
we got our
sick.
epic industrial machinery in the background. Very fitting for this kind of conversation. But the point of that, of course, is that GPS is not guaranteed. I mean, it's on all of our phones. We're used to it. You're used to being able to navigate with it just like as a person walking around the world. But I don't think people know those are literally the same satellites that the Department of Defense uses. There's not like another GPS constellation out there. There's just 31 satellites. And with those satellites, both we navigate around cities and drones navigate a battlefield.
That's exactly it. And I mean, GPS is really, really good. And it's really cheap. Recently, we've seen that commercial drones are able to do like a lot.
Mhm.
And so all of those commercial drones were built on the backbone of having GPS. So you can get a $500 drone off Amazon, and that's really, really useful. But it relies on like this $25 GPS chip. And previously, in the US and in the defense industry, we've built these large, like exquisite systems that, okay, if you're spending $3 million on a plane, you can have a $500,000 like boutique GPS replacement. And so we've actually had that technology since the 70s. Really, the difference now is that, okay, if you can go on Amazon or you can literally 3D print something that has like this incredible use and is really, really cheap, then like you need something that can drop in on that and serve that need that was previously just like reserved for these like custom built systems.
Meaning because drones have gotten so cheap and so good and basically like just cost effective enough that you can have dozens, hundreds, thousands of them deployed.
Yep.
You need all the components of that to also be cheap.
Yep.
Like you can't just have cheap electric motors and you can't just have cheap whatever, like batteries and things like that, like very compact batteries. Like that by itself is not enough. You also need to be able to navigate these things, and that is too expensive or just not good enough to stay active in like a wartime environment.
Yeah, and I mean, what's really incredible is like what we've seen in Ukraine in the past 2 years is like real like peer-powered conflict. And so it's not just like America, we've got these big bases and we're set up in Afghanistan and we can just like project our power. This is like literally trench warfare. And so what you see there is that the drones and like being able to just throw 1,000 of something at somebody is extremely useful. And it's even useful without GPS. But then people come to this problem and it's like, oh my gosh, like my drone can do all of this awesome stuff at home, or like we would like it to do all of this, but now we can't do that because like we can't run an autonomous mission because we don't have GPS. Like we can't, if we're doing like intel, we don't actually know where the intel is coming from. And so people are going back to like very old school techniques a lot of the time where, you know, you're literally looking at some video feed of a tank in the battlefield that you'd like to know where the enemy's tank is. But then you're like doing terrain matching. It's like, oh, I know
yourself,
this farm.
like you're
Yeah.
looking at a picture and you're like, oh, I remember that tree.
A literal person is like looking there and then going on a map on their computer or like their tablet. And so in a lot of ways, it's like very new tech and very old tech because you've got this tablet, but then you literally have to like look at a picture and say like, oh, I'm here. And so what we're enabling is like basically stuff that you could do in California today with a drone because GPS isn't denied. And we're just making it so that you can do that in a battlefield.
Do you want to talk a little bit about just the different kinds of drone that are out there, like on battlefields today? Because it's not just like, you know, I'm sure people are familiar with the DJI, like, you know, fly up and have a camera and whatever. What are the different ways that they're deployed today, and what do those different requirements mean for something like your product?
Yeah, it's a really good question. I think the like coolest, like flashiest kind of drone is like the kamikaze, like the one-way attack drone. And
Are
you
these
can,
usually FPVs?
yeah.
Okay.
And so you can make those really cheap. You can make them for like under $500. You can 3D print them. Then there's also, and this is what the DJIs get used for a lot, like ISR drones, so like intelligence, surveillance, reconnaissance. Those are really, really useful, actually, like just gathering intel. They can be very useful in like telling you where your artillery has hit. Um, yeah, those get like a ton of use. And then I think what we're seeing more of now in Ukraine as well is like these kind of one-way long strike attack drones that can go hundreds of miles, and those are like effectively like a missile basically.
Mm.
And so those are
And
kind
are
of,
those like carrying payloads that they drop and fire separately, or they're not kamikazes? They're not.
you see people are literally filling up like basically Cessnas filled with like explosives and like sending those like very long distance. Um, and I think that that's like a capability that we need to further develop. It's kind of just like when you can do that so much cheaper, and have so much like intelligence on board.
So for those different types of drones, I imagine that they're built differently. They're built different sizes. They're more or less expensive. They're more or less capable of doing certain missions, of course. So which types of those are you guys focusing on most for the nav?
Yeah, it's a good question. I think what we focused on initially are like ISR drones, because you typically spend a little more money on these like surveillance platforms. And so, our stuff is very cheap. It's like under $10,000, well under $10,000, and because of that, like if you have like a $500 drone like that might be like a little tougher to make work. And so just starting on like platforms that do repeatable missions, and so like it's more cost effective basically.
Makes sense. You want to start on the higher end basically, and then work your way to get the product cheaper and cheaper as you get more scale.
Yeah, and the autonomy is really flashy and really cool. Like the full end-to-end autonomy, and like the idea of like, oh, you put something up and then, it just strikes a target, no human in the loop. That being said, like, we're trying to ship as quickly as possible. And so we can take a solution that's like 98% and put it on an ISR platform that doesn't have explosives on it and feel okay about that.
Yeah.
And so, yeah, I think getting that last mile, we want it to be really operationally like proven before we start enabling other use cases.
Yeah, that's one of I think like the most core elements of your guys' story is speed. I mean, you guys started in like February,
Yeah.
and 7 months later,
Yep.
and you guys are already shipping stuff to the battlefield. Like, do you want to tell us more about, like, can you just tell that story of speed and how you guys got started?
Yeah, we started at a hackathon in El Segundo. My co-founder Sasha, he knew one of the people that was putting it together, and we went out there, and then we actually met Carl, our co-founder and CEO there, and yeah, it was just like this kind of, I don't know how else to say it, was like a magic moment. And Carl comes in with this idea, and it's just like, hey, what if we just use like Google Maps, and what if we kind of just like fingerprint? I just remember him saying like fingerprint the maps and match them. It's like, oh, like, yeah, dude, like that's sick. Like, let's do it. And then
So you guys didn't have the idea when you came into the hackathon. You came into the hackathon just with each other, like you and your CEO,
so
and then you found.
no, so Carl came. I guess I should backtrack even a little more. Like Carl, basically, he was at Stanford, spent a bunch of time, like asking around campus and like
Mm.
talking to like veterans there. He was like really, I guess, really, really shaken up by the Ukraine war and wanted to make something like that was impactful there. And I mean, the guy's he's a total genius, and I guess like something clicked in his brain, and it's just like, yeah, like this GPS denied stuff is really like that's it. And so yeah, he came right into the hackathon. He's like, I want to build a fixed wing drone, and it would be really cool if it worked GPS denied. And I'm like, okay, I don't even really know what a fixed wing drone is, but like I could do the GPS denied part. Like let's do that. And yeah, it was like the approach that we took initially was like very naive, but like the problem always just felt like tractable. It's like there's just a way to do this. The information is there. And so yeah, so we put something together at the hackathon. It's kind of like a proof of concept, but it's like, here's a drone. It can carry like this camera. It has this compute on board. We never actually flew the thing, but we put it up on Twitter, and the response to that was just like huge. And I think a lot of that was like noise, but there was actually just like a surprising amount of like really interesting people that reached out from the DoD and from like literally active war zones, and were like, "Hey, we need it. Like, what's going on here? Do you
Yeah.
actually have this? How far out is it? Can we talk?" Um, and and when you start getting in meetings with people like who are mentioned in articles about war in Ukraine, and you like read the article, it's like, oh, hey, I was talking to this guy. He was telling me like this is a real problem. Um, like something just clicked in our brains. It's like we have to build this. And so yeah, from that, I guess the initial demo we built was like a whole platform. We talked to a bunch of people, and what we settled on initially, and we still think this is that the drone platforms are largely trending towards commodification. They're kind of already there. And the first thing, like the first differentiating factor, is going to be the ability to do this autonomy, the ability to position yourself in GPS denied environments. And so like within a week or two, I think we were pretty settled on like, okay, we're just going to make this box and it's going to go on the drone and replace the GPS. Um, and from there, just, well, we were really, really, really lucky. We got into Y Combinator like very early on. And they like, at the time it was like, oh, well, like, of course, like this is
Yeah.
great. Like we're so sick. But like in retrospect, I think they really took like a pretty big bet on us because we were still largely figuring out what the tech would look like.
Hmm.
And just like demoing a bunch of stuff and like putting a bunch of like reading a bunch of papers and just putting a bunch of stuff together. Um, and actually like the first thing that we ever like put in the air, um, it was a it was an Android phone that was running. So I went to like Cricket wireless in the mission, and I got this like Android phone, and I made this little app that would like it would just take a picture every like 2 seconds, and it would hit like an AWS server that I spun up, and it would just like send the picture, and then it would take the position back and then just start like immediately streaming that like over the wire. And I got this little like USB like dongle you can get, and just like we plugged it into like a drone and like put that in the air. Um, I won't say where, but like we shouldn't have done that. Um, and like yeah, and then it was just like flying, and it didn't work at all. But it was like that was like the first. It was like the algorithm really didn't make sense. We didn't like it wasn't there, but it was like, oh, this is flying and it's running our stuff, and that's really cool.
How long did that take from the hackathon to the first flight?
I think we did the first flight like it was about a month after.
That's
Like
awesome.
maybe 6 weeks. Yeah, when it felt like we were, I mean, the whole time, and it still feels this way, like, oh my gosh, we're going so slow. Because, we're talking to people in Ukraine very like day one, day zero, even. We like met folks at this hackathon in Ukraine who like took our idea and like poked a bunch of holes in it, and we had to go back to the drawing board. Um, and so just the whole like I just remember when we got that in there, it's like, oh my gosh, we should have done this like 2 weeks ago. And yeah, just like wow, we're going too slow. We need to get this live like ASAP.
Yeah, like what was the journey from there? So from like started the company, the hackathon, we got funded by Y Combinator. How fast is it? Like a month later or something?
I think we got into YC within like 2 weeks of that hackathon.
That's so
Yeah,
awesome.
yeah,
So okay, you do a hackathon. 2 weeks later, you get into YC. Roughly a month later, you're flying a drone.
yeah.
And then what is that we still have whatever 6 months from then until now. So what's been going on since then?
We hit the books a lot and came up with like a much more like mature algorithm. And that I would say we came to that after maybe 2 months. And then it took us a while to build it out, like maybe 2 months to actually build it and like get the hardware together and have something where we could start to put it on the bottom of a drone. Um, like I think right around like beginning of June is when we started doing flights, and literally just like zip tying stuff onto the bottom of like a DJI Mavic, and just like DJI rocks, by the way, a really good tech, and flying that around and like post processing it and just like looking at it. And then think it was like the end of June. Like we have all this data, we've been doing these recordings, and it's like, oh, like dude, like it's working. Like it's
Yeah.
working, it's doing the thing. It's actually okay. It's a really crazy story how we got in touch with our first customer. So we put together this like Sasha put together like this awesome deck basically of the flights that we'd done. And we started like sending it around to people. And there was a guy in um in the military, in the US military, that I had started talking to like right after the hackathon. And we would just exchange messages, and it's like super cool. And I sent him the deck, and he replies to me like as I'm in the air of like an airplane, like testing our stuff. You can put stuff on the bottom of an experimental aircraft for R&D purposes. So we did that, and like this guy literally messages me as I am like in the air of this airplane, and he's like, "Oh, dude, like that looks pretty cool." I'm like, "Guess what? Like I'm in an airplane right now. Like we're testing this. Like check it out." And he's like, "Dude, we need to get you like out to base." And yeah, then it was like end of June, I think. We maybe early July, we hopped on a Zoom call with them. And they were just like, "Yeah, like, can you guys come out like next week, basically?" Um, and that was sick. Then we did some tests there. We did some like fully autonomous flights. And things just kind of worked well. And so, yeah, that kind of got the ball rolling with those guys, which has been like really great.
Hell yeah. So that's like incredible speed, incredible traction. Let's take a step back and talk about what the hell it actually is.
Yeah,
So
yeah.
it's a you said a triangle. You put on the bottom of a plane. What's on the triangle? What does it do?
So it's 4 cameras. There's 3 front-facing cameras, 1 downward-facing camera, and then an IMU, which is just like an accelerometer and a gyroscope. And so yeah, so we've got that sensor package. We then run that out to basically just like a Raspberry Pi. And
Is
then
that also internal to the unit?
no, so like right now it's like 1 unit, second unit. We we want to get everything like baked together, but it's just easier to keep them separate right now. Like we're really lucky to have found like people who like can make the sensor unit for us. And they're amazing. And so like a lot of that like core, like how do we actually bring data in like from the world, has come from them. And it's really just been like us leveraging and improving on that. Um, yeah, and so then that just runs out to like a Raspberry Pi, which runs a bunch of magic sauce, and then that
Which is your job.
yes,
Your job is to
exactly.
write the magic sauce.
Exactly. And then that just like plugs into the drone, like right into like the serial port, GPS port.
And so from the perspective of the drone, does it know that it's not receiving GPS, or it thinks it is? Like you are giving it the same information that it would receive from just a normal GPS
Yeah.
receiver?
Yeah, exactly. We actually just mock that. There's this standard format. It's called like NMEA.
Hmm.
It's like old format. And it's just serial data. The drone really doesn't know any better. We can actually even like, so it used to be, you can configure 5 things. So let me back up actually. There's this open source flight control called ArduPilot that like there's ArduPilot, and then there's like PX4. Generally, the people we've been talking to use ArduPilot. Um, all drones have like a flight controller on board them. They run this like firmware software on top of it, ArduPilot, and it basically you just need to change like a couple like parameters. Say like this is the type of GPS signal you'll be receiving. Um, Ignore the other kind of GPS signal, and then it just works. And it's actually pretty cool. Now you can just plug it in and like click a button, and we just like auto configure all that for you. So it's like actually like you just plug it in, it just works.
Okay, so you have a machine or you have like basically 2 units. First unit, sensors, sees the world, understands its kind of orientation in the world. That's what the IMU does.
Yep.
Feeds that information into a translator that translates that into position. And so does that mean that inside of the second unit, there's like a world model or like a map basically that you're cross-referencing against?
Yeah, exactly. So the sensor, it really has no clue like where it is. You can think of it as like it's like counting like the amount of steps that you've taken. And it's like it's very good at that, but that's subject to like drift. Like if you were to try to count like a mile in your head just based on counting steps, you would get like kind of close, but then 2 miles, 3 miles, you start to drift. And so then on the like software side, what we pick up off that is we take that data and then, yeah, exactly. There's like a compressed like map. And from that map, we can say like, oh, hey, you just passed that barn, or you are over a field, like we think you're at this field. Um, and so we kind of handle this process of like correlating with the ground truth map and then taking all of that info and fusing it together and then putting something usable into the like flight controller.
Interesting. I mean, it sounds like so that makes sense. It's like image comparison basically. It's like, okay, here's what you're receiving. Like how does that where am I within this picture? Like based on noticeable features or something.
Hmm.
I mean, the questions that come up next to me are like, how good does that picture have to be?
Hmm.
Like, are you just using it like is it literally still Google Maps or is it like
No, we found like some pretty like cheap and decent like satellite imagery, and that works. Yeah, it works fine. There's like some there are some cutoffs on what we can use, which like I can't say the precise like number, but it's basically like this amount of we need this amount of pixels per meter.
sure. Okay.
And so if that's good, then the map like it works fine. And for the camera, um the imagery that we've been taking in, like the cameras that we use on board are actually like quite cheap.
Hmm.
Like the whole point for us is like, oh, let's get the cost as low as possible. And so like right now it's already quite low. We hear from customers like, oh, this is great, like it's really really cheap.
Hmm.
But like the goal for us is like let's make it 10 times cheaper. And so in doing that, it's very essential that it works off of really bad imagery. Um,
Sure.
and out of date imagery too.
Yeah, that was my next question. There are ways to get around visual identification
Mhm,
systems. And so
mhm.
I imagine if I'm an adversary and I want to defeat drones that have this on it, I would disfigure the land. I would destroy that barn or I
Mhm,
would cut down that tree, you
mhm.
know? So I imagine that you have to be resilient to that kind of thing too.
Yeah, there's like a lot of, and this is something we heard from day zero actually at that hackathon. We talked to folks in Ukraine, and the initial approach that we were taking, it just wasn't going to work. And so yeah, you need to be able to like have the barn in your sample or like your reference ground truth imagery and then not see it and still be okay. um and so that's something we're really happy with. It's something that we're excited to test like in the real world or like in a real world scenario, because the closest we've been able to get is basically taking like some maps in the US and then taking like that map 10 years ago and then like flying with that. um, but 10 years in America is not the same as like 10 days in Ukraine. Yeah, that's just something you got to find out in the
Okay.
real world.
And how much of it is so the dumbest way the dumbest way to do it is literally like a comparison of the images like okay, how many pixels are the same color or whatever across this thing? Like that's like probably the dumbest way to do it.
Hmm.
Probably a smarter way, which I imagine you would consider over that is like let's pick out features. Let's define kind of like noticeable features or something within the map and then if we find those then we know where we are sort of.
Hmm.
Like what are there is there other magic that I mean, you don't have to tell us all the magic of course but like like are there other interesting things that you do to just sort of like process the image in a way or like make it less of a dumb like pixel comparison task?
Yeah, I mean, I wish I could say more. It's
Fair enough. Fair
yeah,
enough.
yeah. It's yeah, no, actually if I say
That's
anything,
cool.
my co-founders will kill me.
That's
Yeah,
okay. That's
yeah,
okay.
like
That's cool. That's cool. That means
trying
I'm
to
asking good questions then.
yeah,
That's
trying
fine.
to think of
Uh,
some like coy thing to say, but it's like, yeah, let's
no, you're
just
good. You're
not.
good.
Yeah.
We have to get to the center of the maze of your logo, like the Westworld thing, before I can get the answers. To the okay, we're good. How much of this is like could you do better with different sensors? So I imagine you had to trade that. Like you had to choose between visual spectrum, like whatever. What do they call those? The SAR satellites, or like synthetic aperture radar
Yeah.
satellites or something. You had to choose between whatever, flying an IMU on that or like having some other sensors. Like I'm sure there's
Mhm.
like a ton of stuff that you could have chosen, you could choose to have in the sensor that then you
Yeah.
could correlate. Like why did you end up choosing visible light?
Yeah, it's a really good question. it just kind of is very easy for us to reason about. It's like the approaches that we've taken. Um, there's definitely some tricks, but it kind of just comes naturally.
Mm.
Like, and so I think that's largely like as people that have like come to this problem, and it's like you kind of got to first principles like think through it. Um, it's like what I perceive the world largely through visual information. Starting from that, it just makes sense, I guess. And yeah, as for like the sensors and trade-offs, like I think a lot of it is just like reading the literature, like reading research that's there, and messing around with like existing commercial technology and like just doing like a lot of playing around. I mean, I remember we walked into one of our first like Y Combinator office hours with like a Raspberry Pi with like the Pi camera and like some like crappy Amazon IMU like taped to it. And it's like, okay, like this is what we're messing around with. And so yeah, I think like I mean also candidly it's like you can just do it that way. And so because that's the way that makes the most sense and is the most intuitive, then it's you get there and things start working and it's
Yeah.
like, okay.
There's no need to. I mean, it's good enough and it's cheap enough. I mean, there's an advantage to using like a sensor that everybody else has or everybody
Yep.
else is making. Like, there's a lot of them. It's nothing super fancy and custom. You're using like non-crazy parts, but you're just processing the data in like an interesting way.
Yeah, I think that's like a big thesis that I've developed is like take the cheap commercial sensors and put a bunch of machine learning on top of it. I'm not some like pro PhD in this, but I think when you buy better sensors, what you're buying is like less noise. And AI is it's very good at denoising.
Hmm.
And so I actually think that's like really, really underpriced is like just take a cheap sensor and just denoise it and you can do something for like a hundredth the price. And especially when you can take two sensors like a camera and an IMU that are like decorrelated,
Sure.
um, they're going to be getting noise in like different ways. And so you take that, you apply like a little bit of AI over the top and you can get like really cool results. The other thing I would say is like our stuff works really well in certain conditions, but like there's new capabilities that we're pushing for that will require other sensors. Like we're just starting to dip our toes into thermal. Like when you are working with visible light, there's only so much, like there's only so many photons.
Right.
And if you want to get all of them, you just need to spend more money. And like there's a limited amount. And so um, yeah, I think it's just largely been informed by like what can we what can we reasonably put together quickly and like just iterate on and then put it in somebody's hands and then they say, "Oh, hey, can it do this?" and then we come up with something else.
By thermal, do you just mean like infrared?
Yeah, like yeah, just buying yeah,
Basically, yeah.
yeah.
Okay, so because that's how like night vision and stuff works. It's not that it's some crazy different. It just can see different wavelengths of photons, basically.
Yeah, I mean, and like honestly, when I say dipping our toes into, like, there's this whole world of like, I guess the physics behind all of this that we have like basically been able to like speed run because it's like you get the commercial stuff, it works well, and then you can just like there's this thing that I've learned which is like in software, there's always like an abstraction that you can throw at something. Like in the real world, that's not the case. And so what we've done so far is just like find something that allows us to like move to the software abstraction like as quickly as possible. Um, and so yeah, and then you get to stuff like, yeah, how do you make it work at night? Like now we have to start thinking about like physics and we need to get sensors that work better. That being said, like I'm really surprised by like what you can buy cheaply online.
Mm.
Like in terms of like FPV like thermal cameras, like they're just not that expensive.
Hmm.
Yeah.
Interesting. So, okay, because like at night is like the obvious question for visible light. I
Yep.
mean, I'm sure you've done some testing or whatever for your existing system at night,
Yeah.
and the answer sounds like, I mean, you just don't have enough photo. There's not enough signal there
Yeah.
to like pull out of the noisy data.
Not not yet. We're like trying to push a couple different threads right now to get it to work at night. Like there are some visible light sensors you can use that will pull more light out and like just do that at lower res. So we're kind of pushing a couple things at once. But yeah, I mean it's really just like personally I have no attachment to like any approach. It's just like let's try this stuff and then do what works and then go and sell it to people and see if they like it.
Hell yeah. Like, what are some of the things that you've learned about light or like about like sensors or things like that from going down this rabbit hole for 7 months?
Yeah. Everything that isn't software is like really, really hard. Yeah, like software is really easy. When you start dealing with low light conditions, at every moon phase, there is 1/10 the amount of light. And so
Hmm.
the the game gets like really, really tricky. And I think that that's been like the first thing that we've brushed up on, like the big example of like, oh wow, there is this hard like physical wall. Like it's not just this linear thing. We can't just throw a slightly better sensor. Like we need to go back to the drawing board. Um, and so yeah, I think that applies to everything, right? Like anything you see in the real world is probably like not going to follow some like linear scale. It's going to be something like exponential, something logarithmic, and it's going to take like these like step functions that we do so naturally like in software are not the same like in the real world. Like
Hmm.
you can't just spin up 10 times the light like on
Yeah.
AWS. It's just hard. It's just really hard when you hit that wall. Like that's been the biggest learning for me. Like I went to school for software. I worked on software startups before. It's like you cannot just there is no magic button. There is no way that you just like mock something. There's no way that you like pass it off. There's no way like you can't there's all these tricks you learn in like software to like either not do the work or just like throw compute at it, right? And it's like, oh, we'll just pay a click farm. We'll do this. We'll do it's like you're and there just come some things where it's like you it's like, dude, if you don't know what direction this camera is pointing, like down to like the millimeter, like it's not going to happen. So you need to learn how to get this one thing to work really well. Um, yeah, it's just a very different way of thinking about things.
Totally. So why don't you tell us a little bit more about prototyping and basically how you got from no product at the beginning of a hackathon to actually like shipping stuff to a customer? Because I mean, every hardware startup has to think about this, right? It's like if you're building hardware, things for the real world, you can't just like spend an evening or whatever like hacking things together and then test it, and then if it doesn't work, test it again the next night or whatever. Like you have to think about how to iterate, how to build those first prototypes, how to get them into the world. So you guys have speed run. It seems like you have done this on like speed run, super fast. Like how'd you get that done?
The first thing is I think we've gotten really lucky. Genuinely. The other thing is like finding um finding other people who want to help you. That's like the big advantage I think we've had since day one is like talking to like dozens and dozens and dozens of people who are like, this is really cool. We want to help you. Um, and through that, like entering this new space and basically just having a list of experts who you can go to and say like, hey, I'm thinking about doing this thing. And people love when you say that and then you show them like something really, really bad. And it's like, oh dude, like that's so cute. I'm so glad you tried. Like here, like here, do this. Um, and so we just did that a lot. And like as for like the prototyping, it was like always how do we get stuff into software as quickly as possible so that then we can iterate on it really quickly, and how do we get the data? And so we started off with very like hack together like kind of DIY, like honestly stuff that like a smart like 12-year-old would make right. And then was lucky enough like through a bunch of like intros and just talking to people, it's like, okay, this is the way we want to do it. And then we found like a company that basically makes like the sensors and the configuration that we need them made. And we start talking to those guys, and it's like, okay, we try out the first one. It's like, oh, this is like really good. And then like make a couple tweaks. It's like, oh, this is really good too. And so I think for us, it was largely like asking for help enough that like, it's like if we show people like a sketch of something and it's like, oh, like if you squint at this, you can see what we're getting at. And then they come back and they really helped us. And that just happened enough times that it's like, oh, okay, like you guys can actually make this box that gives us all the data that we need to like make our product work.
Well, I think that's interesting because it's sort of contrary to the popular wisdom that people are receiving from the like Elon companies, right? Because the SpaceXs and the Teslas of the world, like the lesson that people are taking from that is like, I have to vertically integrate. It's like, I must do everything myself. And well, first of all, I think that's good advice for like a big company, not necessarily a small one. So people should always keep that in mind. But at the same time, it's like, okay, sure, like you could vertically integrate everything, but that is gonna go slower. Like the advantages you get in control, the advantages that you get in, eventually having the ability to ramp it up and manufacturing it really fast, you're probably losing. Like you guys, if you guys had to build the IMU from scratch and you had to like have your own, there's no way in hell you'd be moving this
No.
fast. So it's interesting that it's sort of the contrary to the popular wisdom that maybe most people hear for hardware startups.
I think there's also like all these like win-win situations. Would be the first thing I'd say is like, you can't have Dell without Intel, but like if either one of those companies had spent their time doing the other person's job, like they wouldn't have gotten anywhere. And so I also just I think both myself and like so Carl comes from like a very like strong hardware background, and he can make all the stuff that we need made. And then Sasha and I come from like a software background where we have made a bunch of stuff that people don't want. Like we've we've both spent time building startups and spending a bunch of time. Like March of last year, we sat in Sasha's like college apartment in Montreal and spent a month working 14 hours a day to make a company for customers that we didn't understand, that they never asked for. And
What was it?
it was like a basically we scraped all of Twitter and we used that to make this like creator like engagement platform. It's like, oh, like understand your audience and how that
Yeah.
works. Because I thought like there's a bunch of money in Twitter. Like nobody was asking for it. Like nobody, it's like, and actually like we could have done so much more. Like we literally had every tweet like for like months and months. Like we could have, I don't know how we made $5 off that. Like it's actually like impressive, like how bad of a product we made. But like the thing that's great about that, and and we both had that experience on other startups too, and just being like the dude in the garage making something, is you just get beaten in your head like, dude, you don't know if people want it until they buy it. And like everybody says that around like Silicon Valley, which I think is amazing. But then once you've actually done it and you've made it's like, no, like we're gonna go sell this and we're going to get it in people's hands and like make sure we build all the features that they care about before we start worrying about like any part of it.
I mean, that honestly, it sounds like sort of the like the Y Combinator wisdom.
Yeah.
It's like make something people want.
Yeah.
The Paul Graham hymnal. It's like page one, like literally.
Those guys rock.
Yeah. How has YC been for you guys?
Yeah, it's awesome. Yeah, it's really good. I really can't like speak highly enough. It's having like our group partner, Aaron, is just like, he's just been there and he's done this stuff, and like actually having somebody that is fully on your side, that's like bought in, that just listens to all the context of your company, and then you can ask random stuff to, or that can just like having somebody who's opinionated and like experienced it's just great. Like it's so awesome. And like all the like going in, we had our batch retreat, I think it was like end of June, maybe it was early July, and it's like, oh my gosh, like these are just the smartest people in the world. Like this is I mean, I got that feeling when I first moved to San Francisco, and I got that feeling again, like at the retreat. It's just like everybody here is they think through stuff so well. They've done so much cool stuff. Like it's just a really great environment to like make friends and meet people. And it's like, yeah, it's just badass.
I mean, YC historically was not known as like a hardware place. Like actually, so Astranis, we were part of YC back in 2016.
Hmm.
We were the winter 2016 class, and at the time, I think it was like literally there. It was us. It was Boom Supersonic. It was Relativity Space, I think, and maybe those were the only hardware companies in the entire batch. So like nowadays though, they're really leaning into it. Like if you saw that like request for startups list
Hmm.
that they did however long back,
Hmm.
like they really are trying to lead into hardware. So it's cool. It's cool to see companies like y'all, and I'm sure you have other batchmates that are doing crazy hardware stuff too, all doing
Yeah.
it at the same time.
Yeah, I mean, I was just talking like right before I came over here, we had like a YC event and talking to guys that are building like a robot that just goes around your home and does all your chores. Weave Robotics, check them out. They're super cool. And it's like, yeah, it's like, oh my, and also just being able to ask like really hardware specific, like engineering specific questions, and then you get a response from somebody that's worked at this at like an elite company, and it was their job for 3 years to do this very, very niche thing that like if I asked every person I'd met in my life before like 3 months ago, like I wouldn't get a response. It's like that is just crazy. It's like really, really cool.
So you guys, you're in the batch right now. You're about to go through demo day. Is there anything in particular that you want to demonstrate like before you get to demo day?
Yeah, I think it's just more sales to more customers. We are really, really happy with how the tech is performing. We've gotten very long range flights. We've gotten very high altitude. The accuracy is like amazing, quite frankly. It's just now I think it's a matter of like starting off lots of customer conversations. Because in our industry, it seems like things are rather slow moving and they can be very high ticket, but we would just like to kind of prove that there's a lot of demand in a lot of different places. And also just kind of show like, hey, this doesn't have to just be a company that waits around for once a year DoD contracts. Like, there's ways, um, there's hundreds and hundreds of drone companies in the world. All of those companies need our technology. We can just go directly to them and sell to them and be useful. Um, yeah, so just really like really just getting as many data points on that as possible.
Yeah, and I mean maybe that's another thing to highlight about your story too is like traditionally people think of defense and they think slow. They think like the palm cycle stuff. Like it takes like
Hmm.
forever to get in the president's budget, and then you have to program a record, that kind of thing.
Hmm.
It takes like literally years.
Hmm.
But you guys have again done a speed run. Like you guys are actually selling to end customers already 7 months into your company's life. I
Hmm.
mean, so in your mind, does that mean that like mental model that people have of government equals slow is just wrong, and like actually things are changed now, or is it something specific to you guys?
I don't think I'm like qualified to speak on other people's companies, but for us, I think drones in particular are in a really weird spot where largely the commercial offerings are extremely useful to the government and they've been rather slow to adopt them, and they're like the US is really playing catch up. um Last time I looked this up, I think we had about 12,000 drones in the US. Ukraine has said that they need between 1 and 2 million drones this year. So it's just like
Jeez.
an orders of magnitude difference. And all of our drones are, they're six figures, like, or higher. And so back to the question of like, does it have to take a long time? I think for some stuff, uh, especially in defense, it's very like regulated. Like if you want to mess with lasers, you need permits to do that, and you can't do anything there quickly. But with drones, because so much of what is useful in defense is also useful commercially, we're able to move really quickly. And then because there's an active war where drones are literally necessary. I mean, it's like the new AR-15, the new like rifle is it just gives this opportunity where all of these companies are trying to help the war effort in Ukraine. They're making tons of drones, and then they need the drones. They would like the drones to be able to fly without GPS. I talked to a soldier in Ukraine who literally told me that he does not carry a rifle anymore. He just carries like 2 drones. It's like,
Oh,
yeah,
jeez.
like why would I have the extra weight of a rifle when a drone is more precise? It's got like 10 times the range, and like I can control it safely. And like the second I heard that, I was like, oh, holy shit. Like this is yeah. Um and I think that that's the thing that we were really late to is we have predators and stalkers and big platforms that do really awesome stuff, but we don't, like, the US does not have like a man operable drone.
Hmm.
There's not a drone that just like slides into your backpack and you can carry around and either use for recon or use as like some assault weapon.
Yeah. I mean, what about some of the startups though? Because there are startups who are trying to build stuff like that.
Yeah. There's some really cool companies that are working on it. I mean, like last week, I was in Washington with this guy, Andrew, and his company like Black Tusk Robotics, just like building drones that just slide in your backpack and they just work. I think it's just a matter of, and you've got like Neros, like they're making like really cool drones, and those are like actually being used in Ukraine. Um, and so I think we're catching up. Um, that being said, like, those guys are on the cutting edge, and they're also on the cutting edge selling into like a country that really, really, really needs it, like now.
Yeah.
And so the US is just very slow to adopt things. And I think what we've been able to do is basically like go go to other people that need the stuff and are trying to convince the US to adopt it, and then they buy our stuff and it's useful to them. Um, but yeah, I don't know how you like I don't know how you would crack the DoD egg, and we haven't cracked it, right? Like we've made like a, a couple sales, it's working well, the people are happy with it, but like we need to go into the field, like we need to prove that it works there. Like we need to sell tens of thousands of these. And that's like, it's like it's been amazing what we've been able to do really quickly, but it's just like, dude, we don't know. We don't know, and we're not there, and like we need to just continue to push like as hard as possible.
Yeah.
Yeah.
Yeah. Totally. So one thing we have not talked about yet is just the performance of the thing. So do you mind just telling us, like in your testing, like what is the performance that you guys have been able to achieve, maybe even just relative to what is the state of the art otherwise today?
Yeah. Yeah. I mean, the first really great thing is so there are actually like there are a couple solutions that are actively used that are GPS replacements that work really well. Not gonna like say them by name, but um they they are super duper heavy. Uh they weigh tons and tons and tons, and they cost a bunch of money. And and I think that they will always be that way because of the design decisions that were made in building them. And so the first thing that we're really happy with is like our product is extremely lightweight. Like it's in the low hundreds of grams, instead of in the like kilograms. It's also extremely low cost. It's like in the thousands of dollars as opposed to the tens of thousands of dollars. And yeah, like it just works, right? Like we've been able to do tests that are in the hundreds of kilometers, been able to do tests that are over 1,000 meters in altitude. And it's able to track well enough to perform like real missions. And so, like without getting into the nitty-gritty, it's like if if you're trying to map to where that barn is and you're like near the barn, it's like, oh, like we're there. Like you can see it on a map and you can see that you're right next to it. We've got some like really cool really cool graphs, and it's just like you can just see it works well enough. It's good enough for government work, we think.
Yeah, totally. Hell
Yeah.
yeah. And so you've done, can you, maybe you can say a little bit more, not about like, yeah, I understand like no specifics on like the performance, but could you say like the types of tests you've done that have performed well, or like how long, or like how high, like that sort of thing?
Yeah. So we were just at base in the US, doing some like, yeah, long range, high altitude tests. Yeah, we were like it works over 100 kilometers, like yay. It works over 1,000 meters. And you know, and actually, I like this is gonna go into a bit of a tangent, but the thing that was like really great and has been great, with the folks that we've been working with in the special forces is it was like it's actually like pretty scientific. It's like here are here's like an Excel spreadsheet of all the variables we want to test. We're going to go, in distance up by this amount, and we're going to, do it until it breaks. We're going to go up in altitude by this amount, do it till it breaks. And so like that's something I've been like extraordinarily impressed with, from the guys that we've been working with in the special forces is like they are very quick to move. Like, kudos to us for speed running, but also kudos to people in the special forces for being willing to buy stuff from like kids right out of college, that have had a company for 6 months and like buy that and test it and like go to bat for us. So that's been incredible. And just like being able to, yeah, work with folks who are like, hey, we know that this isn't perfect. Let's test the things that don't work. Where it doesn't work, that's okay. We're going to note it. We know you guys will fix it. And like, I mean, having a captain in like the armed forces say like, let's do a linear regression on this is like badass. And it's like that kind of stuff like gives me like a lot of faith. Like I think again, in some ways, like we've gotten lucky to work with just like the best of the best. But in the other, like on the other hand, it's like, oh, like if we have guys like this, like on our side, like that is really cool.
That's awesome. Like that is the future that I want. But what is the future for you guys? Like, what do you think is coming up next? What are the big milestones? Are you going to raise money at demo day? Everybody does.
Yeah. So we got like we're just starting to kick off our seed round. So Carl is just like crushing VC meetings. And yeah, just trying to sell, trying to test more, trying to get it working at night, make a bunch. Like, we want thousands of these like working and live, and we think that we can do that really, really quickly.
Hell yeah.
Yeah.
Awesome. Thanks for coming on, man. This
Yeah,
was great.
thank you so much. This has been great.